Projectiles, horizontal plane, type 2 landing below the plane. So in 1994 we were given a dart player standing 3 metres from a dartboard, which was hanging on a vertical wall. The dart is thrown horizontally from a point 1.8 metres above the ground, and it strikes the board at a point 1.5 metres above the ground. So it's landing just below where it has started from. So it wants us to do two things: calculate the initial speed and then to calculate the speed of the dart on striking the board. So again, just be careful, we're looking for speed and not velocity, which means we need to find our magnitude. So if we start by drawing a little diagram, so we can have our, nothing too fancy, just a matchstick man. And we can see that he's throwing his dart. So here's the plane from which the dart is starting. But of course, it's landing just below on the dartboard where it has started. So if we draw a little bit of a more accurate diagram, we have 3 metres from the dartboard. We also have the height above the ground where the dart player hits the board. So that's going to be 1.5 metres. But it is thrown from 1.8 metres. So this kind of drop off from the direction in which the dart was travelling is going to be a height difference of 0.3 metres. So if we set up our table, we're going to have U, A, V, S and T in the X and in the Y direction. So what we know is the fact that it's thrown in horizontal direction, which means it has no velocity in the Y direction, and we're not sure what it is in the X direction. We know that when it's travelling on a horizontal plane, there is no acceleration due to gravity in the X direction, but it'll be minus 9.8 in the Y direction. V is equal to U plus AT, so therefore that's just going to be U of X. And in the Y direction, we have U plus AT is going to be minus 9.8t. S in the X direction is UT plus a half AT squared. And in the Y direction, UT plus a half AT squared is going to become minus 4.9t squared. So to find our initial speed, we need to look at the information provided to us. So we know that the range is 3 metres. So the man is standing 3 metres from the board. So that means that S of X is equal to 3 metres. So that means that UXT is equal to 3. But we also know that on landing, the dart is landing in a downward direction, so it's landing below the plane. And if we look at our diagram, it's landing 0.3 below the plane. So that would be a negative 0.3. So we say SY is equal to minus 0.3. But we know that SY is equal to minus 4.9t squared. So therefore we have minus 4.9t squared is equal to minus 0.3. So that means that t squared is equal to 3 over 49. And therefore t must be equal to the square root of 3 divided by 7. So now we know our time, we can go back and look at u, and we can say u is equal to 3 divided by t. So u in the x direction is 3 divided by root 3 over 7, which gives us an initial velocity of 7 root 3 meters per second. So that's our initial speed. So then part 2 wants us to find the speed of the dart when striking the board. So to find that, we need our final velocity in the y direction. So our v of x is also equal to our u of x, so it's going to be 7 root 3. Whereas v in the y direction is minus 9.8t. So if we sub in our time of flight, so this is our time of flight, then we have minus 9.8 times root 3 over 7, which is equal to 7 root 3 over 5 meters per second. And therefore, because we're looking for speed and not velocity, then that means we need to get the magnitude. So our magnitude is v of x squared plus v of y squared. So again, really important, speed, not velocity. So therefore, our speed is equal to the square root of 7 root 3 squared plus 7 root 3 over 5 squared. And that gives us a speed then of 7 root 78 over 5 meters per second, or we would say our speed is equal to 12.36 meters per second.